Okay, so NumPy. Okay, what it is about actually. So a few things to note here. It is a mathematical library for doing mathematical computation library. It's a fast, to say in simple words, fast. Okay, so don't worry about the notes and all. It's all here live. So what you can do is you can go for this communityzclabs.com. It's still in beta phase, but still has started sharing this. So this has all the notes and mathematical, okay, the classroom notes and all. Okay, and this has everything. Don't need to write here, so that's what it is. So it's a fast mathematical computation library. This is the first point. Okay, then it is implemented using C. Okay, that means the library internally all implemented using, that's what gives the performance. Otherwise, Python is not the fastest programming language. Okay, it's implemented using C. This is the second point. Third, it's a homogeneous data structure. What is meant by homogeneous data structure? That NumPy can store similar type of data only. Okay, that is what is meant by homogeneous data structure. Okay.
Yeah, when you say like similar type of,
yeah, what it means is it can either hold integers,
only integers,
right? Only floats, only strings. It is okay. Any data structure which is homogeneous data structure means it will contain only same type of data. It's very much like C array. C array also will hold same type of data. It's very similar to that. Okay, then you have okay, and this is a specialist library for doing high dimensional computation, right? Machine learning usually involves converting your data to higher dimension, do some complex mathematics. We'll discuss that. So this guy is much more suitable for that. Then you have
what do you mean by high dimensional data in terms of
high dimensional data means so NumPy is very much used for doing NumPy is also useful for storing n dimensional data. Okay, what is n dimension? What is one dimension? One dimension is an array.
Yeah.
Right? What is two dimension? Two dimension is a matrix. Okay. What is three dimension? Three dimension is a cube. And don't ask me to draw beyond it. Okay. Got it, right? Yeah, we can't do that. Yeah. So that's what these are high dimension. So this is what is the dimension of a cube? It's 3. Dimension of a matrix 2. Dimension of an array 1. So, and beyond it, it is known as hyperdimensions. Okay, or a high dimension structure. Okay, so that is mathematically possible, but if you ask physical representation of that, it is not possible for humans.
So NumPy is the only mathematical library which will be using.
So NumPy is the mathematical library, not the only, but it's a mathematical library.
We'll be using
NumPy, but for Python, it is the only library. Okay, there are other things also. There might be some variations of it, but NumPy is. Okay, then it provides utilities which are mutable in nature. Okay, what it means that it provides a lot of inbuilt functionalities. Like for example, list, you have to add you have to multiply all the values that is present. If you have already seen Python, okay, or if you haven't, okay, so you have what you call is a list. What is this? List is very similar to this is like you have integer here, you have string here, you have float here, you have some other value, you have different values here. Okay, so if you have to do product of all the values that is present here, you do not have direct APIs for that. NumPy is very rich in that. Understood, right? So these are the things that makes it very different. And it is not general purpose, it is of specific purpose software, so it is very fast. Okay, that's all what is NumPy. Now let's see the code and what things it provides. Okay, so first we'll understand. So this is like a huge library. Of course, in the sessions what we will do, we will be covering through the most 80 to 90% of the times whatever you will be using. Okay, because there are this is a low level library. As we proceed further, we realize this is important to understand a lot of things. You won't be writing lot of NumPy code. You have to. It will be limited. Okay, because there will be higher libraries which has made your things little easy. Okay, but we have to know enough NumPy so that we can understand machine learning. That's the focus. So first is, we can see here you have various NumPy initialization technique, right? One of them is empty, 1 init, 0 init. These are like creating NumPy data structure. Let me show it. Okay, you want to import NumPy, so how to do that? Import NumPy as empty. This is like you are importing NumPy as empty. What does this mean? This NumPy is a library, Python library. Okay, and this is the aliasing that you are doing if you are new to the syntax. Okay, NumPy is empty. Now what you want to do? You want to use this library to create an array. Okay, and NumPy is like an n-dimensional array. Okay, it's a storage data structure for n-dimensional array, 2D array, 3D array, and all that. Okay, so what is this empty? If you do, and you can mention here the size. Say, so what it is doing, it is actually returning you a 2x2 matrix array with junk, I mean no initialization done. Understood, right? If you want a cube 2x2x2, you will do this. Understood, right?
So what is it doing, sir? How
It is
that value?
This value is default junk value. This is the data structure that it is written. It is a default junk.
So what is this this function empty is what?
So this will, what will do is it will return you, it will allocate a 2x2x2 NumPy data structure. That means cube 2x2x2, and the values that it will be showing it will whatever memory it is allocating, whatever default it is present there, right? It will return you that. Okay, it will not re-initialize it. An alternative to do this, if you want to, many times you want 0 to be initialized, right? Right now all the values are 0. Okay, similarly you have something like ones. All value initialized to 1. Got it, right? Empty means no values, junk values, whatever is there uninitialized.
Almost a very small value.
Huh?
When you're declaring it is empty, it's almost showing a very little value.
No, it's not about that. Junk value.
Junk.
It's the value is of no importance. It is just whatever was written.
When we are trying to plot a 2x2 matrix, it looks convincing. Like this, when it is 2x2x2, then how do you?
So this is 2x2. I mean, how do you really understand 2x2x2 or so, right? So 2x, you understood this is 2x2 matrix, right? When your third dimension is 2, it means that will repeat 2 times, right? And if I draw again, if I do this, what does it mean? You have a 3-dimensional matrix, and how many times it is repeated? 2 times. That's what it is. Dimensions, right? So you just have to visualize everything that way. Very soon we will realize 6 dimensions, 7 dimensions. Okay. Now let's see. Okay, now
So which one will we be going here?
yeah, for third one.
Essentially.
Okay, this is 0, 1s. Got it, right? This is 0, 1s. Then a similar API is this. zeros like. But the thing is, if pass anything be here, what will it return is, okay, what will it return is, see, D we already allocated, right? 2 cross 2 cross 2 we already allocated. 2 cross 2 cross 2. Now, when you do zero like, what it does is it allocates a similar type of memory. Okay, it allocates a similar type of memory. 2 cross, okay, but it is initializing the values now with zeros. Got it, right?
So D was the matrix, right?
Right, is the matrix.
What was the first step name?
First step is empty. Okay, so similar to zero like, you have ones like, you have empty like, you all of them. Okay, so similar to that. Actually, the thing that you should be focusing in these areas now is get the sense out of it. Okay, the API will be there, a lot of them are there. But even if you don't know, you see the output, you can tell, okay, this is what it is doing. That is the sense you need to build. Yeah, focus. Then you have range. Okay, range. Range in Python also you have range, or any other language also you have range, right? Range, what does it do? NP dot a range. Okay, 2 comma 10. What does it do? It returns you a number, it returns you the data between 2 and 10, but 10 is exclusive. Got it, right? 10 is exclusive. Fine. Arrange. Of course, you get this functionality also. 10 comma 2. Right. So what did it do? It will actually reduce it. This is the step size.
Yeah.
You can increase it, decrease it, and based on the starting and the end value, it will find things. And this guy is pretty useful. And this guy in space. In space is like, between 0 to 1, you want to generate 10 numbers. Understood? From 0 to 1, it generated 10 numbers. 1 is inclusive in this case.
So what did you say? Step size? That is 2 or
minus 1. This is starting point, ending point, step size. Okay. Similarly, here you see linked space is the starting point, ending point, and the number of data between them. And you can see between 0 and 1, it has generated 10 equally spaced data. Got it, right?
So whatever this line space, the data it is being fetching, is it the default data or which is?
Which one is one?
Wait, okay. So line space is something like it's giving the decimal value out based on the numbers what we pass there.
Yeah, I think it will be 0 to 10, and then 10 it will be 0, 1, 2, 3, 4, 5. It's equally trying to divide the total.
Yeah, from 0 to 1.
Yeah.
From 0 to 0 is the starting point, 1 is the maximum value. It is generating 10 values between them. So 0, 0 0.1, 0 0.2, 0 0.3, got it, right? Between 0 to 10, this is the equally spaced value.
Where is 0.9?
After this, the 10 values, see 8, see 1, 1, 1, 2, 3, 2, 4, 5, 6, 6, 7, 7, 8, 8, 9. Okay, then it is, then the value is this. You can see it is equally. The difference between them is
Can you run for 0 to 10, 10?
0 is the starting value. If you do 0 to 10, because last value is inclusive. Got it, right? So 0 to 10, 11 values. Then you can see this. Make sense? Okay, similarly, you have log space. Log space. 2 to 4. Okay, time to, I'll show the output. You guys tell me what does it possibly mean? Tell me. So, what is this? This is 10,000, right? So this is 2 and this is 4. Can you tell me the relationship?
There are 2 zeros and there are 4 zeros. And it is technically 10 is the base.
Say that. You don't say 2040. You say 10 raised to the power 2 and 10 raised to the power 4. Yeah. Okay.
I was taking a different. I was trying to multiply 10 times 2. So that's why.
Okay. So this 2 and 4 means 2 implies 10 raised to the power 2. This is the starting point. 4 implies 10 raised to the power 4. Okay. So this is the starting point. This is the ending point, and you have 10 numbers between them. Okay. Log space. Okay. Then you have random. See, random numbers are very important from machine learning perspective. Okay. The idea of random numbers is required to validate the system, to improve the robustness of the system. Okay. Random numbers. Don't ask me why now. But we will see it, and as we proceed further, we will see a lot of usage of random number. Now it will be difficult to explain. Okay, so just now understand a lot of these things. Initially, you have to understand with the pinch of salt that going forward it will connect.
So here, whatever we are coming across, like log space, line space, and so on, we have to know what does that function do. Right? I'm not getting that actually.
Not getting that.
In Python, when you say like dot append or range of something, list of something, we know actually what it will be doing. But here, I'm not getting line space. Lin space, sorry. So what it does, a log space, what does that mean? What is log space?
This is the function which is generating numbers.
Generating numbers on the basis of
generating number of a friend. The pattern is 2 is a starting point. I mean, 10 raised to the power 2 is the starting point. 10 raised to the power 4 is a stopping point.
Okay.
And it is generating 10 equally spaced number between 100 and 10,000.
So if I tell, like, is that a use, like if you have a x-axis and y-axis, you want to plot 1 to 10 with a division of 1, 1, 1.
You can do that.
So say suppose if it is 2, 4 and 8, is it like 8 to the power of 2 and 8 to the power of 4?
Oh no.
Log means it is 10. Is that?
So if you make it 8, it will generate 8 numbers. This by default base is 10. You don't have to write anything.
Yeah. Okay, base is 10. Yeah.
Okay. By default. So 10 is square and 10 is square 4.
Yeah.
And you have 8 numbers in that range.
Okay.
See, now the number of values reduced. It became 8.
So should we know like how actually this number has been generated, like 193? Like what is actually the difference? 100, 193, 372, and followed by the decimal numbers.
Oh, that is equally spaced. See, you saw this example, right? Between 0 to 10,
like mathematically, should we know?
The difference between this value and this value should be same.
Yeah, it will be the same.
That's what it is. So here, what you're trying to do using arrange, lin space, log space, you're trying to generate numbers. Okay, and this will be required as of when you start doing Digi. Who is Digi? Oh, I think I have. Just a second. Okay, so what is happening here between 2 and 4, it is generated. The difference between them is same, and the purpose is to generate numbers. That's it. Similarly, we will generate random numbers also here. NP random dot rand n. Okay, so if you do this, and this was the way, right? 2.2. Yeah. So if you do this rand and you are passing here 2, 2, 2, what is it doing? It is joining. It is returning a number between 0 and 1. Understood, right? Random number between 0 and 1.
So why it is only between 0 and 1? Why can't it be like 0 and 5? Or
If you want that, you can configure it. Like you have another API for that. And you want 0 to 5, you know? Right. So between 0 to 5, you have this. But 0 to, by default in computer science, you need a number between 0 and 1 more often than anything else. Okay. So this is the API which will give you between 0 and 1. Got it, right?
yeah.
Now, these are the random number generation techniques, right? You can, it's very much required. You'll use this very often. Okay. So now let's proceed further. You can refer to the notes below. So apart from that, what you see is loading from file and all. You have other. Suppose you have this and a NumPy array. I can pass here. So what is this? You're passing list inside this. It is converting a list to a NumPy array. Got it, right? This is a Python list, Python data structure. It is converting list to a NumPy array.
To a NumPy.
NumPy array.
And what is the type?
NumPy array. Array. ND array, that's what we call it.
It's like a one-system vector.
This is actually one-dimensional data only. Okay, if you see the dimension of it, it is 6 comma. Okay, if you we'll get there. Shapes and all, that's the important topic. We'll get. Okay, this is the data here. Now, let's understand accessing various data. Suppose you have random data. Rand in between 0 and 10, size 5 plus 5. This is the 5 plus 5 array. right? So, okay, now you want to access this data. Suppose you want to see this syntax. Huh? This is, okay, if you do this, it means all the rows. If you commas followed by second column, it means all the columns. So if you do this, you will get all the data. It's similar to this. Okay, but why do you need to understand this? Suppose you want to get all the rows, but only first column. You didn't get this. This is 9, 0, 3, 2, 8. Right. So what you're getting? You're getting this particular. You're getting this data. Suppose you want to access first to third data, third column. Suppose you want to access these three columns. Right. So how do you do that? So D colon means all the rows 1 to 4. Is it clear? Okay, 1 to 4.
Earlier it was giving us the output in 1%. Right now it is giving us the output in exact fashion. It was.
That's because there was only one column earlier.
By default, to give return a 1%.
If it is one column, then it will convert the data. If it is more than one column, then it will show the rows. Right. Similarly, if you have to get, can you do this exercise? If you have to get these data, from this data, how do you access this data only? Right? How do you write that?
So we column comma 2 comma 2 comma 3 and column D column comma 2 comma 4 sorry 3 or 4 and then colon
okay, so we'll write 1 comma 4 comma 1. Remember, the last value is always exclusive. 4 will not be inclusive, it will be exclusive. Got it, right? So 1, 2, 3, 1, 2, 3. Fine?
so what is this significance of the past we are typing 1 there that means it will take from first row but second row
0, it starts from 0.
okay
Everything starts from 0, 1. And last is exclusive. So 1 to 4 means 1, 2, 3.
And after 4 we are using comma and 1 that means it is one step. After 4 we are using comma and
that is for column.
That is for column. First column.
Right.
Okay, got it.
The first 1 to colon 2 is for rows and 1 colon for next one is for columns. It is giving you subset of the entire data. Right. These are the fast access methods. Okay, so this is one thing. Now let's understand. This is the accessing part, how you access. Okay, if you want to get certain rows, certain columns, you can try out various options. Just for can you explain this? Just a masala topic. This is your way.
So it is alternative number. Set 2 is that step count.
Step count, right? So If you here you mention whatever you mentioned is a starting point, ending point. So here also, if you want to select alternating data, 7, 3, 4, 9, 5, 7. And you can continue doing these magics. If you want to get data after leaving 2, you can make it 3.
I didn't get it.
This 2 means alternating data. Alternating rows, alternating columns. Okay. Like alternating rows means it will get this page 7, 9, and this last column. Alternating columns will get this. That's it. Clear? Okay. Now that we understand how to initialize, how to create, how to access, we'll now get into the another important topic, which is basically reshaping. Yeah, the reshaping. Okay. Reshaping. What is reshaping? Reshaping means, anyway, this is a very organized data. So what you can do is you go to empty dot random dot random. The starting point, ending point.
So this random numbers will vary every time we execute, right? So it won't be this. Yeah.
And if you want to retain the same numbers every time, you can use seed. 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 Seed.
Okay, seed, yeah.
You just configure some value to seed. You will see every time you execute, getting seed. Okay.
I mean, every time we try to assign that function value to D, it will change, but D will remain same.
NP, just if you do this, NP. If you do this, 058594, right? I think. Oh, I think I screwed it up. I actually, what I've done, I should have be careful with this. This is one thing that problem. So generally, this is the way I should have called it. Set the value. What I accidentally did was I assigned 6 here. Okay. So it has temporarily corrupted the value. I cannot read it anymore. Okay, so I have to load the kernel on, which is not doing now, but this is how you do it. This is how you set it. So every time you execute, you get the same value.
What I was asking is, once you have assigned one array to D by means of this function, every time you will try to see the value of D, that will change? Or
No. Only when you re-execute the run. So anyway, essentially what is happening now is this is your D.
So I do not understand what is that 6 which you passed.
6 is just any number. Okay.
Like we can pass any number.
Any number in there. But just that there's a relationship between 6 and this data is there. So if you as long as you use 6, you will get the same data.
So what is the relation? So say suppose if I passed 10, so
No, that is not something that you can figure out.
Oh.
Right, but one thing is
any number.
But what is guaranteed is if you pass same number again, you will get the same data.
Okay.
That is what it is. Okay. So anyway, so you have this data. Now, what is the dimension of the data? To calculate the number of dimension, you do ndim. Ndim is number of dimension. Two-dimensional matrix, ndim is 2. D dot shape. This is the shape 6x6 matrix. Okay. D dot size 36. Fine, right? So you have 3 APIs ending shape size. But many times what you need is in machine learning, this is a very useful application where you need to reshape the data. That means you need to 6x6 data is there. Sometimes, for example, you need 18x2 or 2x18. You can convert this 6x6 into what? What are the various options? But remember one thing, you have to keep size constant. You cannot change the size. Size. Okay. So it is 36, right? This 6x6. What are the other options? 2 into 18, 4 into 9. Okay, 18 into 2, 9 into 4. These are the possible values, right? So what you can do is, you can do d dot reshape 2 rows 8 columns. Okay, 218. Not it, right? It's the 36, 18 to the 36, right? Okay.
So it was not accepting 8.
8, yeah, because it has to be same size. Okay, now you see d dot. Okay, you understood reshape. Now more things to come. If you see this reshape, if you do this -1 comma 4, what will happen? What does this mean? 4 means 4 columns, and -1 means derive the number of rows. Okay, so what will automatically it will make it 9 rows. Understood, right? You just have to write one of them. D dot. These are shortcuts. Like you don't have to find out. For example, given the size of the data, you just want to make sure it have 2 columns. So what you can do is -1 comma. You will convert the data to
The row it will
derive it.
So rows can be like it will take random any number.
No. It is fixed, right? Total number of data is 18.
Okay.
36.
36. Yeah.
Right. So there is only one way by this row.
Okay.
Got it, right?
it could be only -1, not another -1.
No. It is only -1 is special. This is reshaping utility. Okay. One more thing that you should be knowing here is suppose you have a one-dimensional data. This is very useful. This thing you'll write many times. And be array. Suppose you have this one dimension. You want to convert this into two-dimensional. One-dimensional data without adding without reshape. So if you want to do two-dimension, you do this. Reshape -1 comma 1. It will convert this into two-dimension. Got it, right? If you see the dimension of A earlier, A shape 11 comma one-dimensional data. But if you do A dot reshape -1 comma. Understood? So now what is the shape of it? It is, what is the dimension of it? It is 11 comma 1. Understood? So reshape is returning you a data structure which is one column and derive the number of rows, and you are doing a shape of it one column and derive the number of rows, that is 11.
But here it can be only 11.
In this case,
Size
because
will be only 11.
right, because your total data is 11 only, right here.
It's an odd number. We can't do anything other than 11 1. We can't reshape it in other way.
You can do that.
How?
Like here, if you want, that is right. It's not 11, 10 you can do.
But you said like the
10. I'm doing for 10, not 11. Just to show this utility. Okay, how do you change from one dimension to two dimension? Is it clear?
Okay.
Okay, that one you can make it. This is one case. Yeah.
So these examples are also available in the
They're on for complete examples. At least for you will find all of those here. At least till pandas it is there. Scikit we are in the process, and for Scikit you have GitHub I'm using as of for the classroom notes and everything. Okay, fine, right? Understood what is reshaping. Then after reshaping comes your functional utilities. Okay, functional utilities means suppose you have a they have a array like this. What you want to do is you want to sum.
Sir, one question. So when you say -1 reshape, that is number of rows. We can take any number of rows, but it has to be 2 columns. That is what it says, no, sir?
But I think, sir, we can guess that also because anyway, what the
No, that is just simply the division of it. Okay, I mean, that's why they can get it. It can guess it. It's like just because it's simple logic, right? So
the size is not going to change.
the size is not going to change. So now you see you have all these utilities. NP sum A, that means it is adding all the numbers. Got it, right? We can do all these things really fast. NP dot standard deviation. I'll explain all this standard deviation, all that rest that I want to show now. The standard deviation is 11. Got it, right?
Yeah.
Okay, we'll understand after this. I'll get to statistics and we'll understand what are various. This is the tool to do that. Okay, you want to calculate mean of it. Okay, the mean is 8.4. Got it, right? You can do all this mathematics. So much more than that. Okay, there is a concept of excess in NumPy. Let me first show it. So we had D, right? This is a 6x6 matrix. Okay, there is a concept of excess.
Axis.
The two options. No, there are more than two options. 0, 1, 2. So okay. So just to understand what is 0 axis, this is your 1 axis. This is your 0 axis. This is mean dimension. Okay. So the best part here is if you do this.
What is
It is like direction. Okay.
What do you mean by 0, 1? Is it something defined that 0 means it is the
Vertical. And 1 means horizontal.
What is
2 is height.
But how could be 0?
Huh?
1 in one direction, I understood. 0 in one direction means it is not at all.
No, 0 in one direction means this is the direction name 0. Let me show the next step. For example,
x-axis, y-axis.
Axis
So,
is
axis.
let's see this next time. Axis, if you do 1, what is it doing? What is 1? 1 is horizontal. It is actually summing all the rows.
Yeah.
Got it, right?
Okay.
So that is axis 1. So if you make np dot sum, it will sum all the columns. Got it, right?
They are fixed.
And things are not limited to, like, a lot of people might not know this actually, even if they might be working hard. But see, for this thing.
So it has only 0, 1, 2, that's it.
No. It can always be one lesser than the dimension of the matrix. Okay. For example, Okay, so you can see 4 cross 4 cross 4, 3 dimension, right? So, okay, so you want to sum along the heights. Okay, this is it. Okay, so NP, right? It is the sum along the height. Okay, how can we visualize that? Don't ask me beyond it because it is again difficult to visualize. But if you have to calculate 16, okay, you have to do 6 plus, let me check if it is 16, 6 plus 9. One of the dimension it is picking up 11. Okay, this is 2. Let's take one by one. Maybe let's start with 0. If you are doing 4 dimension, right? So if you are doing 0 and this is your D3, what is your 0 dimension? Calculate. 28, 10, 12. Yeah, I mean, beyond 3 and all that, it becomes very nasty. Maybe I can simplify the data.
It's fine.
Yeah, we can do that. But eventually, you can prove it. If you want, you can make the data simple, reduce the complexity of the data. Right,
So
now you can.
When we use this,
You don't have to use it this way.
Sorry?
You're asking how to use it when you're doing this.
Yeah, actually, when we're dealing with more number of data, large data, so in that case, we don't need to verify.
No, you don't have to verify. Yeah, you don't have to. You just have to do. You might actually not never do this.
Okay.
This is a very low level code that we are trying to do. Okay, you might not actually do it, but you should know it.
Yeah.
That this is how it happens. Okay. That's all. Like in this case, x is 0. I think.
So what is the high level code?
High level code is done using pandas, scikit. Got it, right?
So will companies use this? No.
They will use it because they will use it to generate numbers, do some manipulation, understand. A lot of high level code is internally written with low level code. Okay, so you have to know it. Okay, so this is your access information. Understood, right? If you have this D, you can do this, right? NP max D. Got it, right? It is finding the maximum value along axis 1. Right? This is your D. Along axis, this is your axis 1, so it is finding the highest value here.
In each column.
In each rows. Yeah. Axis 1 means row. Right? Here it is 9, here it is 8, and fine, right? Okay, if you make it 0, you have to find column wise. Just remember this. The way to remember is you write like this 1 right. It's counterintuitive. Okay, this is your 1 right. So you're talking. This is how 1 axis looks like. This is your 0. This is understood, right? This is counterintuitive.
What is it?
Counterintuitive means intuitive is which is very obvious. Like if one being like this was very obvious, right? Straight line. But counterintuitive means this is how it looks like. Clear?
How do you visualize a array actually? I mean, if you tell me like
The NumPy array. So if you want to understand how it internally stores, you have to understand how Python stored list. Okay. So this is Python list. Python list, what happens, right? If when you create a Python list of 10 elements, right? Each of them can hold different type of data. It can hold integer, string, and all that. So in Python, all of them is a reference to some memory or the others. Understood, right? NumPy, on other hand, for its performance, it does not use reference model. It uses stores data in memory wherever it is.
So I have a question here. So when you say that when we are finding out the maximum of the row, right? Axis equal to 1, we're finding the maximum in each row, right? So why is it again listed in a row? Is it because of the list? Why not in a column wise? It is not listed in a column.
Oh, which one, sir?
I guess I got it. So whenever we apply this maximum, it has to result in a list. Only in a matrix way, it results only when we use that size.
It's not a list. It is actually giving you result across axis1. This is the one. This is a NumPy array only.
Yeah.
Okay. And here, how this is the Python list, and this is your NumPy. How NumPy is different. It stores data here only. It does not use the references anymore. Okay, whereas the Python list, it uses reference model.
It's not using indexing.
It's storing the data here itself.
But again, it's maintaining the sequence.
Oh, it's maintaining the sequence. That is why it is fast.
You can't retrieve the data by means of indexing. You can't retrieve the data from an array by means of indexing.
You can do that, right? You did that, right?
Why would you say like you can't? We are not actually storing by means of index.
No. What I say, we are not storing by means of reference. So here it is reference model. Whenever you are trying to access this, you have to go here, then you have to go here to hop.
Yeah.
Right here you get it directly. So performance is anyway better than this guy. Right here it is to hop. From somewhere you came here. From here you went here, and from somewhere you came here. You know the data is here only. So you know that after 5 data also the data will be there. So the performance assumptions and all those things works pretty well. Okay. Clear how it is internally stored? Huh?
I'll try to see more.
Okay. So here it's nothing actually. So see, this is very much like C array. So what happens over here is, suppose you are storing 5 gets stored here in the memory. Okay, I'll show one example. And whereas in the Python list, if you step by, it will be separate outside. So when somebody is trying to access a reach here and you step, it is slower.
Now for me, sir, if it is indexing 0, 1, 2, 3, 4, 5, list of index 4 will be 5, right? Now if you are storing 5 there in NumPy, and I think if I use suppose D is the array, D of 4, is that 5? Then they are giving the same thing. Why is it 2-step in this list and it is
2-step because of it has to here it is homogeneous data. Homogeneous data, I'll tell you why this is new. Wait. Say I can create a NumPy array with all strings. Okay, say you have this NumPy array A, B, C, D, E, F, G, H, I. Right, this is a NumPy array, and what is it telling you? That the size of each data is 3. Right, I store it. Then you do this. You have DN. Huh? You have DN, and DN and I want to access 0th value. You want to override this. Understood, right? Now, do you think what I mentioned earlier? This idea, each of these blocks are of same size, right? When you do this line number 93, what happens? You create a memory. Here it is A, B, C, E, F, G, H. Understood, right? Okay, so it is this. So the size is fixed here 3. So next time onwards, even if you are putting 6 times a, it will actually not store 6 times a, it will store plus 3. Right. That is why your that is how the size is fixed. In NumPy, the sizes are fixed. That is why internally you see the performance.
When it comes to size, it is very much precise to memory. That at that level, I'm not using anything.
I understand. I mean, if somebody is from C background or Malloc, they will understand this. But that's okay. I mean, it's okay not to understand. I mean, it's a lot of things go deeper, right? Okay, now that we understand memory accessing, you have a lot of these functions here.
What is the type you specify?
Huh? Which the U3 is the 3 characters. Unicode 3 characters. Okay, now let's see. Okay, you have NP. If you press tab here, tab, right, you have a lot of such options. Okay. Similarly, you want to apply costs on all the values of D. You can do this directly. It will find you all the costs. You don't have to write a loop and all that. Okay. Similarly, if you have a vector A like this, if you do A plus 5, A plus say 10, you do this, it will return you a NumPy array with all 5, 10 added to all the elements. Okay. Similarly, B is equal to this suppose. Okay. If you do B minus A, it will give you returns. Right. So all those things are there to make your life easy. Right. If you have a complex matrix like this and you go to find the highest value, np dot max. 9 is the highest value. Got it, right?
D was our array. D was our
D was our max. I should write all the things around it. So, and also be aware that there are a lot of functions here. Maybe I can show some of the useful ones. Suppose you have D, A is here, right? So if you do np dot shuffle, again. Okay, say for example, you have this. Let me see. Okay, so you have this np dot choose. Okay, choose A is the data. Suppose 0, 1. Choices. Right, what is it here? These are the choices. Okay, these are the values. These are the options to choose from. So what it chose? It chose zeroth value, one first value, and again 0. That is where 1, 2. Is it clear? So these are the possible values to choose from. 1, 2, 3, 4, 5, 6. These are the indexes you have decided to be chosen. Like 0 is again, 0 is this. 1 is this. 0 is this. Understood, right? Huh? No, that's why. So if you have some data and you want to, like, I'll tell you this. Suppose you have 2 data. Okay, like cat and dog. You want to generate randomize 1,000 times cat and dog. Do you write it manually? No. You can use this utility. This is also useful. That's why. So NP choice here A is equal to NP dot random dot rand int 100 times got it right.
When it's in 0, 2, that means excluding 2, right?
Hmm?
0,
So what I'm telling here is 0 from rand in 0 comma 2, it means 0 and 1. Okay, what are the size? So what will this index? This will return an array of size 100 with 0 and 1, 0, 1, 0, 1, 1, 0, 1, 0 and all that. Clear, right?
But previously you had mentioned 0, 1, 0.
You're taking you
so
told that the index is being chosen.
Yeah.
So now
see, if I do this, it's nothing. It's giving you 0, 1 and all that. Okay, so it's like writing here 0, 1 and 0, 1 many times. Understood, right? It's like writing here that. Then you have choices as cat and dog. Okay, then this is the data. This is 0, this is 1. So what is it doing? Based on where it is 0, 1 coming, it is returning you that value. If you have simple data, small data, and from that you want to generate a lot of data, you can use these cases.
Oh, sir, can you choose this line 108 to 0, 10,
No, the 10 is not work, right? Because this entire index is not available. Here 0 and 1 index is available. This is indexes actually. Okay, these are indexes. You can of course do this 3.
Yeah.
Okay.
Understood, right? So these are indexes, this is the data.
In choice list, whatever is available index, you can use it.
Yeah, exactly. In the choice list, what is the size of the available index, you can use that and A will become index.
So, what are the actual use of these things?
And that's what I'm saying. You actually use these things are useful when you're generating a lot of data. This will be required in machine learning. Take it as a pinch, with pinch of salt that it will be connecting later on. Yeah. So this is useful in generating a lot of data. Okay, let's take a 10 minutes break now. We'll meet at it's 4:25 now. We'll meet at 4:35 precisely. Okay. After that, we'll be discussing broadcasting.
Broadcasting.
That is one of the most important topic of NumPy.
Did you get this actually? See,
The
we
last
say, yeah, the
The
last
last
one.
one, the index is not dependent upon what you are. You can't choose everything. You have to choose according to your choice.
Choices.
If suppose cat dog, that means there is 0 and 1.
Okay.
For the earlier one, there were actually some 7.
Yeah.
Sorry, 7.
Okay, so is it something like this when choices are less, go randomly?
No. Exactly what your choice index are, you can choose. In your choice, for example, cat and dog is there. That means index 0 and index 1 is only available. You can't go for index 3.
Oh, yeah.
It is not there.
Yeah.
Now, if you have 1, 2, 3, 4, for an example, choice is 1, 2, 3, 4.
Uh-huh.
Now you can choose like 3.
Okay, but why did you define just like this? 0 is this one, and 3 is 4, and then again 0 is so. So index of this choice is being displayed as output.
You are choosing index of this,
Yeah,
and trying to repeat this pattern. Like from 0, 1,
yeah,
then
yeah.
third is this one.
Yeah, then why not here?
No, that's what he did. I think, no, what is this?
No, the output is like 0, 1. This is the output.
No, he has
0,
copied.
2, size 100. Okay, so and choice is okay. Forget about that. Cat dog, cat dog. Okay.
Yeah, cat dog is fine. In
Yeah,
cat dog,
in
cat dog you have two index 0 and 1.
Yeah.
Okay. He's choosing let's see.
Can we do this? Oh.
Leave that. You have a cell. Yeah.
Okay.
Here it is cat dog. Okay. Now you first repeat the pattern as. What is this 2?
See, it's like cat, 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 dog, dog, cat, dog. So something like this, right?
It is repeating.
So the choice that index is not repeating, right? That is what I'm asking. So size is 100.
Let's start with cat. Why it is starting with dog? We'll have to ask. When he's not able to understand the question, he'll try to answer something in his own way. Either you take that question, search in a.
He teaches for your frameworks.
Yeah.
How does it teach?
No, he initially told me like, don't go to the classes. Try to either you can go to the contents by your own internet or watch the online course. Really cheap.
Cheap.
Yeah.
Yeah.
But I feel like okay, it's fine.
I think
you will not find that those guys who are having intuition and there, you'll find them in Microsoft. Why somebody will teach the people who are actually master of these things? They try to create. They never try to share the knowledge. There's a much thing like look, this is that. Look, this is that.
Exactly.
Then remain silent and do the thing. So that's what I'm saying. Either you ask him again and again, if you're not able to. The same thing happened in one class. They asked something, so, and then he called me like, okay, I found like he's having something like this. If you are really interested, then you could just process. Sorry, online you can purchase something. I think somehow I feel like engaged when I come and discuss.
Come here, I know. At least here we sit dedicatedly at home, like so much of distraction. That's what I feel.
Yeah. Or if you are up to that level, then definitely you will not come. If you can sit down silently and do the work.
Exactly.
You can do that in a professional environment. In home. I think he's telling something wrong here. See, the earlier example, that one and this one is completely different. You could see there what he was. What I believe is, suppose first one is 0, second one is third, that is fine, it took 1 and then 4. The third one, it is not 0, it is not 0th index. Might be it is repeating in that fashion.
Exactly. Did you pay the registration?
I have already paid 12,000. But wherever you go, you find this kind of pattern. You will not find someone who is very much the guys who are actually working on project, they will be able to tell you the exact answers, but they never prefer to teach. I think if you will also do your own project, after some time you will feel like what you're asking, the same questions.
Will we be getting hands-on experience?
They told like at the end will help you to build your own project, 2 to 3 projects. But I don't trust on them. I had to work on my project.
How do you choose the project? Where do you choose?
See, I went through some of the in Kaggle. Once you go through Kaggle, you find spectrum of project. But where to start, how to proceed, that is a very disturbing thing for you. For that, you have to start a lot in it. Some project will be is this. Everything is explained and what then I have to do. But the basic thing is like once you understand this, how they are using these functions, then probably you can think like, okay, suppose I am from a real-time environment. In my profession, what I am seeing, that is kind of challenge for me. Okay, that's how they put question in category. Businessmen want to do this kind of predictions. These are the data set. Use the data set to do prediction. In similar way, in a real-time problem, what I am facing in my work, I can choose that. And if I have the data set, then I can use it for my prediction. It's too early to say. Yeah. But these are important. I have heard from people who are attending interviews, they're asking directly these questions.
Oh.
In Python also the same thing. They ask like, can you write a code in list comparison? So instead of writing 5 lines, just write it in 1 line. There's nothing but you have to remember in what sequence you have to write.
Exactly.
They look for that. Nobody asks these intuitions. In India, you will not get those jobs. So that's what we discuss always, like get into a profession first, get a job where we can interact more number of people, figure out like what actually happening in the market. Then we can use our own idea.
Do you are you in some forum, data science or data related forums?
We both are in Kaggle. So, you just attend this, right?
Yeah, so Kaggle.
We are not aware of Kaggle, right?
I know Kaggle. Yeah, I'm in Kaggle, but I haven't used because I didn't know how to use because I don't have any knowledge.
Okay. The best thing is just follow this first. Next thing is in Bangalore, a event happens like meetup. Okay. Meetup.
Okay.
In meetup, you can it's a free of cost. You just register and go and attend the session. It will be just like what you learn, it is there only. In meetup, what they will do, but you will understand what they are doing exactly. It is fully like in market how the real-time problems are getting resolved. In Kaggle, what is the challenge question and how they are solving. You could see, you will find some very intelligent guys there.
Yeah.
You will feel like ashamed of like how they will be able to solve on what, but fine, but you can understand. You check meetup.
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 Meetup. Oh, meetup.
Okay. So once only we went there, we found like this is too much.
Wow.
Like, and then we are just planning like 2 months we'll prepare and again we'll join. There you will find young guys, they are trying to fix the problem. But yes, you can understand like how they are solving. Meet up on AI, meet up on ML, you can type, then you'll find a lot of events there. But the only disadvantage is that they are not trained.
Okay. So what do they do then? Is there some session or someone will be explaining?
No, they will not explain nothing. They will. It's just like there are communities in outside of India where they every weekend they come and start to work on some project. Okay. So here they'll just explain you. Okay, Kaggle question number this and this question demands this, they'll explain a little bit and they'll ask you, okay,
start
debugging.
Okay.
Now, if you are not aware of, in the competition, there is a race. Like there are some people just quickly say like, okay, my accuracy level is this much percent, 70%. And that guy who will be leading the session, he will know it's not fine. Even if you will be not 1% even, you will find. I'll not come again. But yes, that's it.
So, is there some conferences kind happening in Bangalore on data?
I mean, I try to figure out those things, but you will not find somewhere the programs where you can learn. It's like just like people who are aware of the basics. They're trying their knowledge to attempt those stuffs. They're trying to fix the problem which are having $50,000 price money.
Oh.
Just like some geeks, they are trying to fix something possible. The guy who is leading, who used to lead the session, they are PhDs. I don't know who is funding this. Might be the background. There is some organization who is trying to head up this event. In community, you can join, but I think Kaggle is the best. Have you joined Kaggle?
Yeah.
Are you getting the newsletters?
Yeah.
Are you going to the competitions?
No.
You should try. But
because I don't know anything, right? So that's why.
That's what I told. Even if you go to the meetup, you'll find people are doing good things. Like in the last meetup when we were there, the discussion was like the CSV contains data for arrival airport and flight which is waiting to the airport and arriving in the airport in a country. For example, USA there are 230 airports are there. So flight destination, flight arrival, arrival time, destination time, and there are some other parameters. Now we had some challenge there, like how do we choose something like that.
Okay.
I was not able to even run that challenge. So I thought, no, it's not the right time. The guy who was actually leading, he told me like, don't quit. You sit here, do whatever you want to do, but you should get some output. But that was too tough even at that time. It was in Reliance Jio office.
Oh.
But we'll go again.
Now, when are you planning to go?
Not right now. We have to go through these things. Because the people who are there, they're already capable of doing those things. And they'll help you. You want to follow some challenge question, they'll help you like inside GitHub you will find profiles, right? For example, my name is Nihal, I'm a data scientist. You go to my profile, there I'll explain, I might have explained some of the challenges. CSV data and challenge. They could help that also. But don't worry, you can jump into the middle. It's a well explored shop already outside of the world.
Oh my god.
Even if including this data, this is becoming this is something. We took some 1 month to figure out like we are learning everything, but if somebody will ask us like how to use the data set, what algorithm you will be choosing in order to apply this data set to get the model, we didn't have an answer. We do not have an answer. We are still just going through different steps. Do you know Andrew NG? Okay, let's type Andrew NG. ANDREWNG. There is in YouTube, you'll find Andrew NG's ML videos. He's the best guy in machine learning world. So he has Yes, uploaded some videos. There is a 10-minute, 15-minute, 10-minute, 15-minute. Just try to go through them.
Okay.
In the first go, you will not able to catch that what he's saying. But go slowly, again slowly, you'll understand. These are you are using these things there.
Wow.
This is not a very small stuff.
I know it's vast.
Don't think like 3 months and then you'll be able to
Do and yeah.
That's what we come to conclusion after a couple of weeks. This is not easy. Just need more time. When they says AI, probably I believe using normal code also I can create a AI app. Okay, like friend finder. Check if the institution is same. Check if the workplace is same. Then after 100 verification, just share this list to someone in case that's a kind of AI, isn't it? With a for loop that is possible. But we're not looking like that. And if my data set contains 125 crore people, probably that might work.
I know.
My server will handle. It will check for all 125. We need some model.
Hey, can I have your number?
94565.
95565.
940. But I'll be 4020. But I will remain busy almost most of the time. Just text me.
Okay. So this is WhatsApp number, right?
4020.
WhatsApp number.
Yeah.
Neil name.
It's 4020.
Oh, sorry.
Neeladi.
Neeladi. Just in case if you come across any forum as such, right?
Yeah.
You can let me know and then I can also join.
Right. The purpose of ours was like to learn the thing what they are doing really in the market, but they are so advanced.
The room has been very cold. If you want, you can switch it off. Or else we'll have. Okay, guys. Let's resume. So let's start with.
So just one thing. In that IN triple one, what we did is like we choose the index 0, 3 and 0 from the choice list, right? So it is 1 for 1. You could understand that. But when in the 109, the index are only 2, 0 and 1.
Index are the possible values are 2, 0 and 1. And how many values are there? 100.
But how then it is giving us the output?
Because 0. This is 1, right? 1 is dog.
Is it because of randomly it is taking randomly
cat
and dog?
It is generating 100 numbers between 0 and 1. Here you see, right?
Yeah.
This is equivalent to pasting the entire thing over here, and it is giving from 0 and 1 only. It is giving you 0, 1, 0, 1, 1, 0, 1, 0, all combinations.
So can I make 0, 1 instead of 0, 2?
No, then it will give only 0.
You are excluding the last.
Excluding the last. It internally does that, right?
I guess there in that 1, 2, 3, 4, we had mentioned 3 or something because of the index. So we had to mention the maximum value there. The number won't be ignored, right, sir? 0, 1, 2, 3, 4, 5. So the maximum number we can include is 5.
5, right.
So 0, 5, 0. It can be like
it
that.
Can be, yeah. And it can be more than that also.
More, you said it can't be more than that.
No,
that's a max.
Number of.
Okay, yeah, that one. Okay, yeah.
Okay. Now, Okay, so this is one thing you have to understand. What is this? What is a vector? Okay, I'll discuss again. What is a vector? Is it's a row of data. This is a vector. Okay, 5, comma 6, comma 7. This is a vector. Okay, one row of data. Okay, this is another vector with same dimension. 7, 7, 3. Got it, right? So all these are represented as like this x bar. That is the reason is vectors. So NumPy is pretty useful in doing vector maths. What is vector maths? Vector maths is doing operations between data which looks like this. Frankly speaking, in entire machine learning, no matter how you get the data, you will be converting the data into vector format. Okay, you might get image data, you might get string data, you might get tabular data, you might get anything like that. You will convert that into vector, right? You will convert the data into something like this format, and only when you do this, your machine learning can work. So now,
So why that conversion is required?
that is because all machine learning understand only vectors.
Only vectors.
And nothing else.
It's not because of simple or one dimension.
No, it only understand vector, because machine learning internally is nothing but vector calculus, right? So it has to convert everything to vectors.
So if it is a multi-dimensional, we have to choose to take the one-dimensional.
I mean, I cannot say yes or no either, because for backing it out, I mean, for backing the answer, I have to explain some context. But at this point, just pause that. Huh? Okay. So now let's create a vector. This is the vector that we are creating. NP.array. This is your array A, right? This is your data. Okay, this is a vector. As you can see, it's very similar to this, right? One row of data. So if you do A plus 10, what happens? Yeah, added to all of them. So what is actually, this looks very simple, but there are a lot of things around it. What is happening? The vector and a scalar value is added, right? I mean, addition operation between a vector and a scalar value. Got it, right? Addition vector and scalar. Got it, right? Okay, so that's what. So your 10 is a vector value, and this is the scalar value. But it's not that simple.
Is it something like A plus IJ format?
Yeah, I mean, of course, that is. I mean,
that is called vector and scalar.
So actually, when you write this, it means something like this: collection of things like this. I'll discuss this later, but since you brought it up. Okay, when you write A bar, okay, it means this. So here you call A01, A02, A03. Here you call A11, A22, A23, A21, A22, A23. Right, and when you, I mean, this is what is vectors. I mean, actually, collection of rows. Okay, and if you write like this, so notation varies. If you write A1 bar, it means you're talking about this row. Got it, right? That's it. Don't worry about a lot of things now. Okay, but what happens now? We have this. We have a vector which looks like this, right? Which looks like this A. So we have a 11, 12, 13, 14. 12, 13, 14, 15. This is a vector. Now when you have to add 10, what it internally does is it actually converts the scalar value 10 to something like this. Right? It converts the scalar value to a vector which size is same as the scalar. Vector. Right? It converted this previous 10 into something like this. Now the operation between them happens. Right? And the resultant becomes like this. 21, 22, 23. Got it, right? This is this mechanism that is happening here of converting a data of one dimension to another dimension. This is known as broadcasting.
This is how the concept is defined inside.
Yeah. So when you understood, right? So your 10 was a scalar. Broadcasting means repeating some contents.
Yeah.
So that is what it is doing. Now, okay, so this was about one dimension, right? So let's see. Now, if you have to increase the dimension, okay, say you have a data which looks like this. Right? 5, 7, 2, 1. Right? Two-dimensional data. Now you want to do a plus operation between a data which looks like this. 7, 7, 7, 7. What will happen now? How can you do this operation? Because the thumb rule is you can do operation only when two vectors are of same size. Okay, you cannot do this now. Okay, what is the dimension of the first guy? This is 2 cross 4, right? This is 1 cross 2. Right? So we cannot do this operation here. What do you do? What do you do?
We can broadcast that second matrix.
Absolutely. So actually, what you can do, anything which can be repeated and made similar, right? So this case one dimension, so you can repeat it and make it similar.
So 7, 7.
So you'll actually, extend it 7, 7, 7, 7, right? And then the operation will happen. So you can 5 plus 7, 7 plus 7, right? This is also known as broadcasting. Okay, so this is when it was 2 dimension and 1 dimension. There is one more case. Okay, so let's take a case when you have a 2 dimension, you have a matrix which is 3 cross 4, and you have another matrix, yeah, and which is a 2 cross 4. Got it, right? So this is 4 columns. Sorry, 3 rows, 3 columns. This is 2 columns. Okay, how can you do operation between them? Can you do it?
It will be 3 plus 4.
Hmm?
It will be 3 plus 4.
Which one?
Will you be converting 2 cross 4 to 3?
You cannot write.
We are saying addition.
You have to do addition between them.
Multiplication is possible.
No, even addition, multiplication, dot product is not possible.
Yeah.
Okay, so how can you do operation between them? Technically, so these all in broadcasting that I showed you earlier, right? This guy, or your code, your NumPy can do it automatically without you telling anything. But in this case, you won't be able to do. Okay, so we have to tell something here. Let's see. So A is equal to NP array. A dot shape is there. NP. We have B. Okay, so now you cannot do this directly. It will throw error. Broadcasting not possible. But you can make it happen by some tweaks. Okay, please understand this. So what you have to do, you have to somehow add. Okay. Three plus 4, right? So we can do 3 plus 4 plus 1, rather 1 plus 3, 3 plus 4. What did I reshape? Let's say this B dot reshape 2 plus 1 plus 4. Okay, so here what is happening here is, see, the rule is we cannot do directly. Okay, but what you're doing here, we are inserting one dimension here, we are inserting one dimension here. Okay, so first you have to accept and embrace this logic of adding one dimension to the data will not change anything in the data. Okay, it's like adding one dimension because this size is still 1 cross 3 cross 4, right? This size is still 2 cross 1 cross 4. Okay, okay, so now by adding one dimension, what has happened? You are following to the thumb rule. The thumb rule is that either to enable systems broadcasting, either the size should be same, or whichever it is not same, it should be 1. You just made it happen.
Or whichever not same.
Not same. For example, our earlier dimension was 3 cross 4, right?
Yeah.
And 2 cross 4.
Yeah.
So these things are same. Okay, but these things are not same.
Yeah.
So the thumb rule is, when they are not same, this is, by default NumPy cannot do broadcasting. So what do you have to do? You have to convert this data into 1 cross 3 cross 4. Okay, such that you are adding one dimension here. So this data is equivalent to this data. No problem there. Okay, and this data, what you're doing, you're adding one dimension in the middle. Okay, so that it becomes 2 cross 1 cross 4. Okay, so what happens once once in any of the dimension it is 1, okay, your internal NumPy can repeat in that dimension. You saw it earlier also, 1 cross 4, it repeated there. Okay, so it internally will repeat it into 2 cross 3 cross 4. This guy also 2 cross 3 cross 4.
Okay, so is it something like you should add only one or any number?
No, one. Only when it is 1, NumPy can do this multiplication over there. Do this broadcasting thing over there. Understood, right?
No.
Okay. So what happens over?
You need to say like.
There is no one correct answer to that. First, understand that. I mean, if I have added 1, 3, 4, it's okay if I add 3, 1, 4, and 1, as long as this rule is intact. The rule is your internal broadcasting will happen only when the operation will happen only when sizes are same. And to bring sizes are same, broadcasting will try to do that. And broadcasting will happen, if it's possible, only when either in whichever dimension there is a mismatch, one of them should be 1, so that it can replicate there, it can multiply things there.
So can you display A and B's matrix? First column.
When you're adding 1 in the beginning and 1 in the middle of them, you mean to say this has become 3-dimensional? And how when you are becoming same after that manipulation? We said like 1 cross 3 cross 4, isn't it?
1 cross 3 cross 4.
There was a 2-dimensional matrix 3 cross 4. When you're adding 1 in the beginning, do you mean to say is that a 3-dimensional matrix 1 cross 3 cross 4?
This is the 3-dimensional matrix. You are converting 2-dimensional matrix to 3-dimensional.
But
2D.
So in the previous question, that is 2 cross 4, and we broadcasted like by adding another row of by 777, right? So why can't we do the same here? Even we have to add even here we need to just add 1 row, right?
Here, no. By adding 1 row only, this is the dimension that should follow. Okay, your finally dimension before you can do the operation should become like this.
Yeah. So I got it. So in the previous question you said 2 cross 4 and 1 cross 4. We added 777 and then we added, right? So now it is 2 cross 4 and 2 cross 4. So in this problem, so why can't we add just 777s to make it 3 cross?
So now, so the thing here was, of course you saw me 777, but actually it can be different data also, right? Now what do I add in the, now we understand this is what B is. Okay, now what do I add in the last row? First row or this row? Got it, right? If it is 1 data, you can replicate it. 2 data, then what do you replicate?
Okay, I got it.
Understood?
No, this one I didn't get. Like how you're converting, after even you're converting into 3-dimensional, how the dimensions are becoming same?
Dimensions are becoming same because of broadcasting. By rule of broadcasting, wherever there is 1 dimension, it can replicate there. So because of broadcasting, 134 is converted to 234 and 214 is converted to 234. Then the operation happens.
That is replicating and making it 234.
So we are just converting our data so that data is compatible for broadcasting.
But I could have also done a broadcast with the second matrix 2 cross 4, like not happened. 4 cross.
You can do a lot of operations. You can do a different way, but eventually this is what you.
Now, is that going to happen in 4 cross 8? If I broadcast?
No. 4 cross 8. No. You need 1 dimension, 1 data.
Okay. I can do the broadcast in 1 dimension, not in more than 1 dimension.
No, you can do that, but the dimension should be 1.
Okay, I can choose both X, Y.
Right.
I can choose only either X, Y, or Z.
Okay, so this is the benefit of, you can ask, this is a complex thing, but what is the benefit out here? The benefit is because of this, you can do fast, you can do a lot of computation really fast. Okay, I'll show you. For, this is a very useful operation in machine learning. Yeah.
Sir, here one more question. You did like B dot V shape 214, right? Can we do it like 241?
Yes.
Anything.
And anything, as long as you can see, as long as this thing is matching.
Yeah, yeah.
Yeah. Okay. As long as you do that, you can do anything, no problem. Okay. So why do you need broadcasting is to do a lot of computation faster. Okay, I'll give you some examples. Okay, say this is a common use case in distance vector calculations. Suppose you have these points and you have these points, right? What do you have to do? You have to measure the distance between this guy, this guy, this guy, this guy. You have to find out for each of these points which is the closest blue point. Understood? For each of red point, you have to find the closest blue point. How do you do technically? You loop through all the blue, red points or whichever is lesser, then you find. So again, you can understand 2 loops, dirty code. If you write that sort of code in machine learning, a code will never finish. Okay, so to do these operations faster, okay, you can use broadcasting. How? Say for example, the blue guy is 4 row, 2 cross 4, right? No, sorry, 4 cross 2. This is your blue guy, right? BLUA and array. This is the first guy. This is the second guy.
You have implemented the blue dots, right?
This is blue. Okay, this is red. Okay, so can you do this? Blue minus red? You cannot, right? 4 cross 2 and 2 cross 2. I want to find all possible distances between them. So what can I do is, this is 4 cross 2. So what I can do is dot reshape 1 cross 4 cross 2 dot reshape 2 cross 1 cross 2. Right now, what you get here, this is the distance for the first red point, like 2 cross 2, from all the 4 cross 4 points, all the blue points. Right, this is the entire distance. Similarly, this from 4 cross 4, this is the distance from all the blue points. You're doing in one shot, no loops. That is the benefit of broadcasting. So it is internally used in all sort of vector calculus. Okay.
But are the values are correct? I believe, for example, if I take the extreme left to blue dots, it is the y-axis is fixed there. But you have changed the y-axis there also.
What? This is correct.
Is correct?
Yeah. It's do the subtraction, right? 2 cross 2 minus 1 cross 1 is minus 1 minus 1. 2 cross 2 0 0 0. 2 cross 2 2 minus 3 minus 1. Sorry, 3 minus 2 1. 3 minus 2 1.
No, I was telling it, the blue dots, the vector what you are using to represent the blue dots, those are not. The vectors what you are using to represent.
Oh, that's a temporary thing. Okay, so you are saying the coordinates of this. Oh, I just wrote it randomly, right? Okay, yeah, that's all for today.
This community GK lab, right? Can we get the syllabus, sir? How will be proceeding for the next 2 months?
Yeah, you can open the website itself. Okay, it's pretty much that. There are some changes. You can more or less, like tomorrow, we'll be doing some statistics understanding.
Tomorrow, this is the same time.
I think no, tomorrow class is in morning.
It's in the morning.
Morning.
What?
Around 10 o'clock.
Sir, I have 9 to 1:30.
I'll check with Amitesh because evening we have in Mumbai. Yeah, Anupam. So we are about to wrap up with this broadcasting. Did you follow all the things that I discussed?
Yes, sir. I just followed everything what you discussed right now.
Oh, okay.
Yeah, it's
So we'll notify you tomorrow's class timing by today evening itself.
okay. So you're wrapping up today's class with this?
Huh?
You're wrapping up today's class with this?
Yeah. Wrapping up today's class because NumPy is the introduction of NumPy. So tomorrow we'll be doing statistics part.
Okay. So, sir,
Okay.
can I get the video of what you have taught me today?
Yeah. Start recording. Okay. So I'll stop recording.